So guys, in this video we are going to deal what are the main factors which are going to affect the rate of the reaction. So we are going to see the factors which are going to affect the rate of the reaction. That is how fast a reaction can proceed by altering certain conditions over there. So first and the foremost factor, let us say that what does your temperature affects on the rate of the reaction. So before going to the direct part, that is okay, if you are going to increase the temperature, your rate of the reaction increases. If I say so much bluntly, of course there will be a question how. So let us just recall certain things what we have done in our lab classes. So for example, if I will give you a container which is having certain amount of water and I will say you to add some salt to it, of course, so you will be going on adding the salt to it and you will be stirring it. So once a particular limit has been done, what happens further? This salt remains at the bottom as the residue. But what I have said is, I have given you certain quantity of the salt and I have said you to soluble all the salt given to you. But in the cold condition, what is happening? Some salt is left over. Alva. Why this is left over? We know that if for example NaCl is dissolving in water, why? Because it dissociates as Na plus Cl minus. This dissociation is leading to the solubility of this salt. But once it is not getting soluble means what? Whatever the salt you have been putting, it is not getting dissociated. So now what I am going to say to you, okay guys, now you just heat this container and then you go on add the salt and stir it. So what will be now your observation? Of course, whatever the salt, how much ever the quantity I have given to you for that particular solvent, on heating, the salt gets soluble. That means what has happened? From NaCl, for example, it has been dissociated to Na plus and Cl minus when you are increasing the temperature. So what has happened? The reaction has proceeded. So in simple words, we can just say that on increasing the temperature, what happens to the rate of the reaction? Rate of the reaction also increases. So this is the first factor which is affecting your rate of the reaction. Coming to second part, let us see it be your concentration of reactants. Concentration of reactants. So let us take an example over here. Of course, we are knowing dilute acid, yes, dilute HCl, and that of your concentrated HCl. Okay, let us take the one more reactant over here, our hand. Okay, that is your hand. This is a simple example what we can see in our day-to-day life. So for example, if this HCl, dilute HCl falls on your hand, what happens? There will be not much issue. So what happens when this dilute HCl falls on your hand? There will be not much an issue. But what happens if you're taking concentrated HCl and it falls on your hand? Of course, your hand gets burnt off. So this is a reaction which is taking place on your body itself. So what has happened? On increase in the concentration, the rate of the reaction has also increased. So in simple words, what we can say, on increasing the concentration of your reactants, what happens? The rate of the reaction also increases. Okay, this is the second factor. Coming with respect to that of your catalyst, of course, if you are remembering, we have plotted a graph. So if this is your graph, we have said that when you are using your catalyst, yes. So this is the extent of reaction if I say. So here is your number of the molecules if I choose. So when in the absence of the catalyst, what happens? Your graph will be in this way. But this is in the absence of catalyst. Absence of catalyst. But when I am using a catalyst, what happens? It will be in this way. Yes, like this. It would be moving like this. The same graph. And whatever the peak over here is there, this is called as the of your activation energy. So what we can see in the presence of catalyst, the activation energy is much smaller than that of the activation energy in the absence of catalyst. So what happens if a reactant has to form a product? So in the absence of catalyst, what happens? The activation energy is more, and in the presence of catalyst, the activation energy is less. So for a reactant to give the product, what I have said, it has to cross this energy barrier. So when you are using the catalyst, the energy barrier decreases. So what should happen to the rate of the reaction? Easily the reactant will form the product. So in the presence of catalyst, what happens once again? The rate of the reaction increases. Okay. So with the increase in the temperature, the rate of the reaction increases. With increase in the concentration of the reactants, the rate of the reaction increases. And with the presence of the catalyst also, the rate of the reaction increases. Coming to now the fourth factor, which is called as the nature of reactants. Nature of reactants. So this is very much important, because for a chemical reaction to occur to give from reactant to product, we know that the reactant should break in order to give the product. For example, if I am choosing as H2 plus Cl2, I should get it as what? HCl. That means what? This HH1 bond is existing. Similarly, with respect to 1Cl molecule, a bond is existing. So in order to give a HCl, what should happen? This bond should break, this bond should break, and a new bond has to form with respect to that of your H and Cl. So now our overall reaction depends upon this bond. So what in terms you can say? So whatever the nature of the reactant is there, it is mainly depending upon what type of the bond exists between the two of your reactants. If a weak bond exists, of course the rate of the reaction will be faster. But if a strong bond exists for that of your ionic bond, so then what happens? It needs some much more time to break this bond and then to form a product. So basically when you are dealing with the factor of nature of the reactants, here we have to say that the rate of the reaction depends upon the nature of the bond existing between the reactants. Coming to another point, this is called as that of your size of the reactants. What is that? Size of the reactants. So basically in the further chapter you will be able to understand what happens means we are mainly seeing that this reactants, whatever, if two reactants are there, they are going to collide with each other and then they are going to form the product. But what happens? More effective collision leads to a fruitful product. That is, in simple words, we can say that how greatly it is colliding, that much amount of the greater percent your product will be obtained. So that probability of the collision, what happens? It increases, yes, when the size of the reactant decreases. Size of the reactant decreases. For example, let us choose that you are having two footballs. Yes, let's check. Of course, when they are going to collide, of course, only these two footballs are going to collide. If I take one more football over here, one more football over here, one more football over here. So what is the major probability? In a particular time, there is a probability that only two footballs can collide. That is, minimum number of the reactant molecules can react. But in the same while, if I am going to take your crazy balls, okay, if I am going to take a crazy balls, so of course what happens, since the size is less, of course this molecule colliding over here can also collide over here, can collide over here. That means what? The collisions will be greater when the size of the reactant is less. So as the size of the reactant decreases, the collision frequency increases, and that in turn what happens? Leads to the increase in the rate of the reaction. So just you have to keep in your mind, as the size of the reactant decreases, the rate of the reaction goes on increases. Coming once again to the factors, we have seen that with increase in the temperature, the rate of the reaction increases. With increase in the concentration of the reactants, the rate of the reaction increases. With the presence of the catalyst, the rate of the reaction increases. The rate of the reaction mainly depends upon the nature of the bond existing between the reactants, and we have also seen that as the size of the reactant decreases, the rate of the reaction also increases. Of course, I have also mentioned the presence of sunlight. Do remember that in the presence of sunlight also the rate of the reaction increases, because it will be producing it like your temperature part. Greater the temperature, of course we have seen the rate of the reaction increases. So sunlight is very much important for your free radical reactions. Of course we have seen, and we'll be majorly seeing it when we are doing with that of your polymers. Basically with respect to that of your free radical mechanisms, in mainly initiated, or we can say the increasing the rate of that of your free radical reaction takes place with the presence of the sunlight. So these are some of the important factors which is going to relate with that of your rate of the reaction, that is how fast a reaction can take place.